something to this one, the only
Good evening, students. There is some problem in the system. So for this class, I've taken this tab. Let me continue up with electromagnetic waves. Look at this. Electromagnetic waves have frequency higher than 9√2 megahertz by the reflected of ionosphere of a particular day at a place. What is the maximum electron density in the ionosphere? It's a standard result. That is the maximum electron density in the ionosphere is in terms of 5 into 10 power 12. What is electron density? Electron density means number of electrons per unit volume. In the ionosphere, it is of the order 10 power 12. So you can choose 5 into 10 power 12 per meter cube. Look at this question. Given the wave function in SI units, the wave function is this. They are asking you to find the speed of the wave. Speed of the wave means you have to find V, isn't it? Now, this is called the amplitude, the general equation of the wave. Sine, I will multiply this pi inside. So it will become sine of 3 and the coefficient of t is what? Omega. So the coefficient of t is omega. The coefficient of x is k. Now they are expecting you to find the speed of the wave. How to calculate the speed of the wave? You know that the speed of the wave is nothing but you know that the speed of the wave is V is equal to F lambda. And you know that omega is equal to 2 pi F. And also you know that K is equal to 2 pi by lambda. This is from the base first PU chapter. It is PU 11 physics. Omega is 2 pi F. K is 2 pi by lambda. And V is equal to F lambda. You know that V is equal to F lambda can be taken as 2 pi F into lambda divided by 2 pi. Just I am multiplying and divided by 2 pi. Why I am doing this multiply and divide by 2 pi? Because now you can write this lambda by 2 pi as what? 1 by k, right? 1 by k. So lambda by 2 pi, you can write this as 1 by k. See, V into 1 by k. So V is equal to omega by k. So please remember, this is from first PU concept. That is 11th physics. This is from waves chapter. So what is the velocity of any electromagnetic wave? It is V is equal to omega by k. V is equal to what? Omega by k. Now you can use that formula here to find that V is equal to omega by K. So V is equal to omega by K. V is equal to what is omega? 9 into 10 power 14 pi by K. 3 into 10 power 6 pi. You can cancel with pi and pi. What is 9 by 3? 3 into, when 6 comes up, it will become 14 minus 6. 14 minus 6 is nothing but 8. So V is equal to 3 into 10 power 8 meter per second. One more thing, students. You know that the electromagnetic waves travels with the speed of light, isn't it? You know that the electromagnetic wave travels with the speed of light, and you know that the speed of light is of the order 10 power 8 in terms of 3. So without solving this, we can guess the option B. But why I have solved? Because this is the problem based on the first PU formula. How to find the velocity of any particular wave. To find the velocity of any particular wave, we are using the formula V is equal to omega by K. So omega is 9 into 10 power 14. K is 3 into 10 power 6. So on dividing that, you are going to get 3 into 10 power 8 meter per second. Got it? Yeah. Look at the next problem. The wave of wavelength. What's the wavelength they have given? 5,900 Armstrong. The sodium is having the length. Let us say the length is 2.4 centimeter. Now they are asking you to find the number of oscillation in this length. Let it be number of oscillation is n. So this is also based on the concept of the first year. Let me analyze like this. Now, you know the waves is like this. Correct, no? This is the waves. This is one wave, lambda. So in the first wave, what is the distance? Lambda. If I go to the second wave, one more lambda is added up, right? So for the second wave, for the two number of waves, what is the wavelength? 2 lambda. Similarly, if I have 3 waves, how many wavelength we have? 3 lambda. So generally we can tell the number of waves is nothing but what? N times of lambda. If there are n number of waves, what is the total length? N lambda. So total length is n lambda. And the total length is n lambda, where n represents the number of waves. Number of waves is nothing but the number of oscillations it is covered. So from this, what is the formula for the number of oscillations or waves? It is length divided by the wavelength. So how to find out the number of oscillations or the number of waves, students? The number of oscillations or the number of waves is nothing but the length divided by the lambda. Length divided by the lambda. Now you can use that particular formula here. You can use that particular formula to find the number of oscillations. Number of oscillation is nothing but the length divided by the lambda. What is length? 2.4 centimeters. Centimeter means 10 power minus 2. Lambda is 5,900 Armstrong. 10 power minus 10. Now, this can also be taken as 2.4 divided by 59, or you can take this as you can take 0.59. You can take this as 0.59 into 10 power minus 6, because 1, 2, 3, 4 digits we are shifting towards the right. So it becomes 10 power plus 4. So it becomes 0.59 into 10 power minus 6. 2.4 into 10 power minus 2 as it is. Now, 2.4 whole thing divided by 0.59. You will get approximately 4 point something 06 into 10 power minus 6. When it comes to numerator, it will be plus 6. So it will be equal to what? It will be equal to what? Minus 6 plus 2. Minus 6 plus 2. That becomes plus 6. Plus 6 minus 2 means 4. So 4.06 into 10 power 4. So this is the number of oscillations where it is undergoing. So 4.068 into 10 power 4. Actually, this you can make it as 10 power 4. So option B will be the right answer. So length is 2.4 centimeter. So centimeter will be 10 power minus 2 divided by the wavelength 5900 angstrom, that is 10 power minus 10. You can take that 5900 as 0.59 into 10 power 4. So plus 4 minus 10 I'm taking as minus 6. So 2.4 divided by 0.59 into 10 power minus 6. When it comes up, it becomes plus 6. Plus 6 minus 2 will be plus 4. So 4.06 into 10 power 4. So this is the number of oscillations. So option B will be the right option. Yeah. Come to this. If c is the speed of the electromagnetic wave in the vacuum, its speed of light in the dielectric constant k and relative permeability mu. Relative permeability is mu r and dielectric constant is k. How do you define? You know that the speed of light in the vacuum is given by c is equal to 1 divided by root epsilon naught into mu r, or c is equal to epsilon naught into mu naught. How do you define the dielectric constant k? How do you define the dielectric constant k? It is nothing but epsilon divided by epsilon naught. Epsilon divided by epsilon naught. Now, how to find the speed of light in that V? V is nothing but 1 divided by root epsilon mu. Isn't it? So V is equal to 1 divided by root. What is epsilon from this? Epsilon is k times of epsilon. K times of epsilon naught. So k times of epsilon naught into. Similarly, what is mu? K times of mu naught. So this will become what? Similarly, you can tell this as relative permeability mu r. Instead of k, you can use mu r because they have given the relative permeability as mu r. So in the place of mu, you can take mu r into mu naught. So V is equal to 1 divided by root of. I will keep k and mu r as it is. Now the remaining parameter is epsilon naught and mu naught. That can be taken as 1 divided by root epsilon naught into mu naught. And you know that this value is equal to C. So clearly this tells V is equal to C divided by root of K into mu R. So what is the formula for the V? C divided by root of K into mu R. So you can go with the option C. You can take up the option C as the answer. Yeah. Come to this. Dimension of 1 divided by epsilon naught into mu naught. You know that C is equal to 1 divided by root epsilon naught into mu naught. Squaring on both the side. That is C squared is equal to 1 divided by epsilon naught into mu naught. So what's the formula for 1 divided by epsilon naught mu naught? 1 by epsilon naught mu naught is nothing but the square of the speed of light. Square of the speed of light. So what is the dimensional formula for velocity? Dimensional formula for velocity is nothing but L1 t minus 2. Sorry, t minus 1 for velocity. So c square means L1 t minus 1 whole squared. That is L power 2 into t power minus 2. So what is the dimensional formula for c squared? The dimensional formula for c squared is L power 2 into t power minus 2. So L power 2 into t power minus 2 is there in the option C. Therefore, what is the dimensional formula for 1 by epsilon naught into mu naught? L power 2 into t power minus 2. Any doubt? Yeah. Look at this. The magnetic field between the plates of the radius R is given 12 centimeter. Separated by a distance of 4 mm. Parallel plate capacitor of capacitance C, that is 100 picofarad, along the axis of the plates, having the conduction current I is 0.15 ampere. 0.15 ampere. Now, how to find out the magnetic field for this parallel plate capacitor? Now, between the two plates of the capacitor, here, in between the two plates, whatever the constitute of this positive charge is there, that will produces a magnetic field that will be into the plane. The next capacitor is having a negative plate. That negative plate is having a magnetic field into the plane. If one is into the plane, the another one must be the out of the plane. Since the two fields which are equal and opposite, you can tell the magnetic field will be 0. So the net magnetic field should be magnetic field due to the positive plate minus the magnetic field due to the negative plate. Since both the plates are having equal charge, it constitutes the equal amount of the current. So there will be no current between these two. So the magnetic field will be 0, because please remember, between the two plates, the conduction current will be 0. Here it exists another current which you call it as a displacement current. So which current is constituted between the two plates of the capacitor? Between the two plates of the capacitor, the displacement current will constitute, but the current due to the conduction electrons That is what we considered as the conduction current. That conduction current value will be 0. Since the conduction current is 0, the magnetic field produced by the element between the two plates of the capacitor is 0. So option A is the right answer. Protect? Yeah. Coming to this, they are given the two equations in vacuum. Vacuum means absence of air. In that vacuum, the electric field is given by E is equal to E naught sine kx minus omega t. B is equal to B naught into sine kx minus omega t. Both are in the same phase. Look at the difference. Now you have to search for the two state between the two waves of the electromagnetic waves. One is due to electric field, the second one is due to the magnetic field. Both the electric field and magnetic fields are existing in vacuum. Which of the following is true? Which of the following is true? You know that velocity of the wave c is equal to omega by k, isn't it? V is equal to omega by k. This is general formula what I'm writing. Now, I want in terms of velocity in terms of electric field. That is nothing but E naught divided by B naught. So V can also be taken as E naught by B naught, which is equal to omega by k. So on cross multiplication, I am going to get E naught into k, which is equal to B naught into omega. E naught into k equals to B naught into omega. So option A is the right answer. So for the given electromagnetic wave equation, by equating the velocity as omega by k, V is equal to one second, students. They have given the two equations, right? E is equal to E naught sine omega t minus k. Hello. Okay. I will adjust. I will adjust now. I will adjust. So E is equal to E naught sine omega t minus kx. Magnetic field is given as B naught into sine omega t minus kx. You know that the speed of light c is given by c is nothing but omega divided by k. C is also defined as E naught divided by B naught, which is is equal to omega times of B naught. Yeah. I hope now you can see the question, students. The radio wave have a frequency F. Frequency is 90 megahertz. Now that is entering a ferrite rod. Ferrite rod means it is a magnetic material, where epsilon r is nothing but 10 power 3 and mu r value is 10. What is the wave velocity and the wavelength? Velocity you have to find, and also you have to find what is the lambda value. Now, they are asking you to find the velocity not in the air medium. They are asking whenever this frequency enters into a fertile rod. What happens? You know that velocity is given by the formula V is equal to 1 divided by root of epsilon into mu. Epsilon into mu. Or you know that in terms of speed of light, it is c divided by root of epsilon r into mu r. Sir, how you got this? You know that epsilon r is epsilon divided by epsilon naught. So on substituting for epsilon as epsilon r into epsilon naught, I am taking this. So finally you are going to get what? V is equal to c divided by root of epsilon r into mu r. Now velocity is equal to, you know that c value is 3 into 10 power 8 in air medium divided by root of, what is epsilon r value? 10 into mu r value is 10 power 3, that is 10 into 10 power 3, that is 3 into 10 power 8 divided by 10 power 1 into 10 power 3, root is 10 power 4. Root of 10 power 4 is how much? Root of 10 power is how much? 10 power 2. So V will be equal to 3 into 10 power 6 meter per second. So what is the velocity of the wave when it enters the ferrite rod? When it enters the ferrite rod, the velocity of the wave is 3 into 10 power 6. Now, student, I will look on the option. One is 3 into 10 power 8 meter per second. Option C is also having 3 into 10 power 8 meter per second. These two are not possible. Why these two are not possible? Because their powers are not matching. Even 3 into 10 power C is also wrong now. Only first option is correct, that is 3 into 10 power 6. Only is correct, that is there in the option B. Therefore, option B is the right answer. Sir, why you have not calculated the wavelength then? Because among the 4 options, already we have deleted 3 options, isn't it? So only one option is left out with 3 into 10 power 6. So option B will be the right answer. So how to calculate the wavelength then? It's easy. Velocity is equal to F into lambda. So what is lambda from this equation? It is V divided by F. So lambda is equal to V is nothing power 6, 10 power 6 will get cancelled out. What is 3 divided by 90? It is 1 by 30. 1 by 30 is nothing but 0.033 recurring. This can also be taken as 3.33 into 10 power minus 2 meter wavelength. So the speed of light will be 3 into 10 power 6 meter per second. And the wavelength will be 3.33 into 10 power minus 2 meter. So you can tell which is the right option. Option B is the right answer. I hope students you can see the font size now. I think it's better compared to the previous thing. Yeah. Let us take up the next problem. Yeah. Mu naught is what permeability of the free space is given. Epsilon naught is the permittivity of the free space. What is the speed of light in the vacuum? You know that the speed of light in the vacuum is given by 1 divided by root epsilon naught into mu naught. This can also be taken as 1 divided by root of epsilon naught into mu naught under the root. So what is the speed of light in the air or vacuum medium? It is 1 divided by root epsilon naught into mu naught, that is under the root. So option C is the right answer. Yeah. Look at this. K is the dielectric constant they are given. E is the electric field. Now they are asking you to find the displacement vector. ID. What is the displacement vector? Now, how you can define the displacement vector? Displacement vector is nothing but ID is equal to epsilon naught times of rate of change of electric flux d phi E by dt. d phi E by dt. Correct? Or not? Into what is d phi E by dt? That is the rate of change of flux. You know the definition for the flux is nothing but electric field into the areal vector. So I'm going to take E times dt, rate of change of area, let it be dA by dt. Now, if you are introducing the dielectric constant K, then electric field in the dielectric constant, this is if it is in air. Other than air, then electric field intensity will be E divided by K. So, electric field in the given medium is electric field in air medium divided by K. Remember this. This you have studied in the first chapter of the 12th physics. So, electric field in the given medium is E divided by K. So, it should be like epsilon naught times of E divided by K. That should be the displacement vector. Here, area is the vector. It is perpendicular to that. So, this current vector is going to act in which direction? It is dA by dt. But we are going to find this as the current density J. So, the pointing vector, the displacement vector will be epsilon naught times of E divided by the K. So, option C is the right answer. Epsilon naught times of E divided by K. This we have solved. Yeah, come to this. Yeah. Source is transmitting the electromagnetic wave of frequency. How much of frequency? 8.196 into 10 power 6 hertz. Now they are expecting you to find what is the wavelength of the electromagnetic wave transmitted from the source. You know that the speed of light in the vacuum medium is given by C is equal to nu into lambda. Then what is lambda? Lambda is nothing but C divided by nu. What is C? C is 3 into 10 power 8. What about the frequency they have given? It is 8.196 into 10 power 6. So lambda will be equal to what? It is 10 power 6 they have given, right? Yeah. So what is 3 divided by 8.196? It is 0.3660 into 10 power. When the 6 comes to numerator, it will be 10 power 2. 8 minus 6. Or this can be taken as 3660 into 10 power minus 4. This 10 power 2 as a base. So 0.3660 into 10 power 2. 0.3660 can be considered as 3660 into 10 power minus 4. So lambda is equal to 3660 into 10 power minus 2 meter. You know that 10 power minus 2 meter is nothing but centimeter. So 3660 centimeter. So what is the wavelength of the transmitted from the source? 3660 centimeter. So option D is the right answer. Yeah, let me try this. Yeah. There is a plane of the electromagnetic wave that is traveling along the x direction. Wavelength is 3 mm. Lambda is 3 millimeter. Now the electric field is acting along the y direction. Electric field is acting along the y direction with amplitude of 66 volt per meter. 66 volt per meter. And you have to write the equation for the electric and magnetic field. Now, if the wave is traveling along x direction, electric field is along y axis, then magnetic field must be along which axis? Magnetic field must be along the z axis. So, how to write the equation for the electric field and the magnetic field? Student, you know that the electric field along the y axis, if you want, you can write that in terms of what? E naught into either the sine function or the cos function. But observe in the option they have given all cos function. So I'm going to write cos. It is omega t minus kx. So E naught should be there, cos should be there, omega t minus kx. Sir, why kx? Because kx is the velocity of the wave which is traveling along x-axis. So it is kx. And you can guess easily, students, here the amplitude of the electric field is given 66 volt per meter. This is not there. Here also not there. Here also not there. But look at the option D. Option D is having 66. Amplitude of the electric field 66. So easily you can guess the answer as 66 cos 2 pi into 10 power 11 t minus x by c. So after substituting this omega and k, you can get the answer. But easily you can guess because the magnitude, amplitude of the electric field is given as 66. So option D is the right answer. That is 66 cos 2 pi into 10 power 11 t minus x by c. So option D is the right answer. Got it? Yeah. Let me take one or two more problems. Yeah, I will take the one graph question over here. Yeah. Look at this. The wave is traveling along the y direction. Light wave is traveling along the direction y means velocity is traveling along the y-axis. And they are telling that the electric field E vector is along x-axis. So electric field is acting along x-axis. And the magnetic field vector at that time is along which axis? A very simple problem. Now you know that the velocity vector v vector should be equal to E vector crossed with v vector. You know that velocity is acting along y-axis. Y-axis means j cap is the unit vector. Electric field is acting along x-axis, so it should be I cap. Crossed with b vector, we don't know, let it be n cap. Now you know that formula, simple formula, I cross j is equal to k. J cross K is equal to I. K cross I is equal to J. So here J means K cross I. Or I can take this as I cross K as minus J. Or I will write I cross minus K is J. Instead of writing minus here, I am writing that minus inside the bracket for K. So I cross minus K is J. So what we can write? So J cap is equal to I cross, in the place of N cap, I can write it as minus K cap. So I cross minus K is nothing but J. I cross minus K is nothing but J. So in the place of N, what we have? Minus K. N means magnetic field. So magnetic field should act like minus K, means it should be minus Z axis. Minus Z axis. So option D is the right answer. So please remember, if the velocity of the wave is traveling along Y axis, electric field is acting along X axis, magnetic field is acting then in which axis, means it is acting along negative Z axis. So it should be minus K. So it should be negative Z axis. So option D will be the right answer. Got it? Yes, students. So these are the different varieties of the problems in electromagnetic waves. And this is a small chapter itself. This completes the part 2 of the physics 12th standard. So from the next class onwards, I'm going to start up with 11th standard physics portion. And from that, we are using the PPTs. We are not using the PDF. We are using the PPTs. So by the help of the PPTs, we are going to start up with the first few portion, so that I will start up that in the next session, students. Okay. I hope you understood the problems here. Sorry for the inconvenience, which is not visible. I think initially I didn't notice that. Anyway, this will not occur in the next classes because we are using the PPTs. So for each question, you will be having each slide. So we can solve it on the same slide sheet for that particular question, students. So I will stop at this stage. We'll continue in the next class with the first few portion of part. Thank you.